Good day, everyone! This segment is for grade 12 students who are studying physical science, but of course, everyone who is willing and interested to learn is welcome to join us. Today we will talk about one of the most interesting questions in science. How were the elements formed? The calcium in our bones are elements. How were they formed? The air that we breathe are made up of elements. How were they made? Are you ready to answer these questions? If yes, then please make sure that you have a pen and paper with you so you can write all the things that you will learn from this episode. I am Teacher Iman, and I welcome you to the very first episode of Science Eskwela TV, where you can learn science concepts in fun and easy way. I have identified 8 important concepts that will help you understand the topic more easily. Let's see how many of these concepts you already know. Answer the true or false questions with Science and Eskwela. Science, Eskwela, are you ready?
Yes, teacher.
Okay, for our first question. True or false? Elements are made up of subatomic particles called protons, neutrons, and electrons. The correct answer is true. Yes, it's true. Protons are positively charged particles. Electrons are negatively charged particles, and neutrons have no charge. It is important for you to know this if you want to understand how the elements are made, because these are the ingredients in making an element. If you want to know how to bake a cake, you need to learn the ingredients first. The same is true with learning about element formation. You need to know what the ingredients are. Question number 2. True or false? The identity of an element depends on how many neutrons it has. The correct answer is false. The identity of an element depends on how many protons it has. An atom that has 1 proton is hydrogen no matter how many neutrons and electrons it has. If you add another proton to an atom of hydrogen, it will stop from being a hydrogen and it will become helium. Imagine if you have a friend who is very talkative and then one day he came to class and he was very quiet. What do you usually say? Hey, you're so quiet today. That's not you. Now imagine you saw an atom of hydrogen on the road. If that hydrogen has 2 protons, what do you say? Hey, you have 2 protons. That's not you. You're not hydrogen. You are helium. If you don't know how many protons an element has, just look at their atomic number and it will tell you the number of protons of that element. It is also possible for a proton to turn into a neutron and for a neutron to turn into a proton. When this happens, the identity of an element changes. Question number 3. True or false? Lithium is one of the elements formed during the Big Bang nucleosynthesis. The correct answer is true. The very first elements were made a few minutes after the Big Bang through the process called Big Bang nucleosynthesis. Most of what were formed were hydrogen and helium. However, a few lithium and beryllium were also made. If you look at the periodic table of elements, you will notice that the ones at the top are the elements that I mentioned: hydrogen, helium, lithium, and beryllium. This is because these elements are lighter than the ones at the bottom. They are lighter because they have less protons and neutrons in their nuclei. Question number 4. True or false? Nucleosynthesis combines nucleons, protons, and neutrons to form new elements. The correct answer is true. Nucleosynthesis came from the words nucleo, which means nucleus, and synthesis, which means creating something new by combining separate materials. Studying about the formation of new elements may sound overwhelming at first, but it's actually very easy. It's really just all about colliding ingredients and then combining them to form a new element. Question number 5. True or false? The Big Bang is an explosion. The correct answer is false. Contrary to popular belief, the Big Bang is not an explosion. The word explosion is misleading. That is why we prefer to use the word expansion to refer to Big Bang. According to the Big Bang theory, the universe was extremely small, even smaller than an atom. It was also extremely dense and extremely hot. But 13.8 billion years ago, it began to expand, and the formation of most light elements occurred just a few seconds after the Big Bang. Question number 6. The universe was colder 13.8 billion years ago. And the answer is false. The universe was very hot billions of years ago. However, it cooled down as it expanded. This fact is important in our study of element formation. It tells us that there was a time when the universe was hot enough to form elements, and then it stopped because it cooled down. Question number 7. True or false? The higher the energy of the particles in an object are, the higher the temperature of that object will be. The correct answer is true. Temperature is a measure of the average kinetic energy of the particles in an object. The higher the energy of these particles are, the higher the temperature of the object will be. You're right, Quella. Look at the two sets of molecules on the screen. Let's all imagine that these are water molecules. The molecules of the one on the left has more energy. They are moving faster. The one on the right has less energy. Which of the two do you think is hotter? If you think that the one on the left is hotter, then you are correct. If you are too shy to tell your friends that you are hot, maybe you can tell them that the particles inside you have a lot of energy. If they watch this, they won't be confused with what you mean. The temperature of the universe can also tell us whether or not it's possible for new elements to be created there. When it's too hot, the particles have too much energy. They just get destroyed when they collide. If the particles lack energy, they will just bounce upon collision. No new element made. However, if the temperature of the universe is just right, protons and neutrons can combine when they collide. When that happens, new elements are made. Last question. True or false? Mass can be converted into energy. The correct answer is true. We learned from the law of conservation of mass that mass can neither be created nor destroyed. However, Einstein's theory of relativity, E is equal to mc squared, tells us that mass can be converted into energy. It is important for us to understand and to know that it is possible for mass to be converted into energy. Later, you will see that when elements are made, energy is released. Now, where does this energy come from? It comes from mass. So how did you do? Were you able to answer everything correctly? If not, then that's fine. It only means that there's still a lot to learn. And I know that you're very excited to learn about how the elements were formed. So take it away, Professor Atom. Thank you, Teacher Eman. Did you know that protons and neutrons formed a few seconds after the Big Bang? At first, the universe was so hot and the particles were so energetic that when they collided, they just got destroyed. However, the universe is expanding, and as the universe expands, it cools. For a few minutes after the Big Bang, the temperature of the universe reached a point where the protons and neutrons could combine when they collided. Through this process, new elements were made, and we call this the Big Bang nucleosynthesis. How does this Big Bang nucleosynthesis work? Protons and neutrons collide and combine to form deuteron. Deuteron is an isotope of hydrogen that has one proton and one neutron. How do we know that this deuteron is an isotope of hydrogen and not of any other elements? It's because it has one proton. And all atoms that have one proton is hydrogen. Soon another neutron collides and combines with it to form triton. Again, this is an isotope of hydrogen because it has one proton. Then again, another proton collides and combines with it to form helium. We know that this is helium because it has two protons. Most of what were formed were hydrogen and helium. However, some lithium and beryllium were also formed. One way lithium was formed was through the collision and combination of helium-4 and triton. And one way beryllium was formed was through the collision and combination of helium-4 and helium-3. As the universe continued to expand, the temperature dropped to a point where the particles no longer had enough energy to combine when they collide. They just bounced. The universe was able to create a lot of hydrogen and helium and a few lithium and beryllium. That is the process of Big Bang nucleosynthesis. As you can see, it is very straightforward and very easy to understand. All you have to remember are the words collision and combination. Now that we know how the light elements were formed, the question that remains is, how are the elements heavier than beryllium formed? So far, we've learned that we need enough heat so that the particles have enough energy to combine when they collide. However, we know that the universe can no longer provide that heat because, like what we learned earlier, as the universe expands, it cools. Now, can you think of a hot place where heavier elements could possibly form? If you thought of the sun, then you are correct. Yes, some heavier elements were formed in celestial bodies like the sun, the stars. And that made me think of the nursery rhyme Twinkle Twinkle Little Star, and I'd like to share to you the senior high school version of that song. Twinkle, twinkle, big, big star, now I know how hot you are. Heavy elements exist because of you, gold, calcium, oxygen, and silver too. So what have we learned from this song that I hope you sang in your head? The rhyme tells us that stars don't just twinkle, they do more than that. They make it possible for elements to form. It also tells us that stars are not little, they're big, and they only look small because they're very far away. Lastly, the rhyme tells us that stars are so hot, they can provide energy for another type of nucleosynthesis, the stellar nucleosynthesis. When elements are formed inside a star, we call that stellar nucleosynthesis. It all starts with a stellar nebula. The stellar nebula is the birthplace of the star. It is called such because it is where the stars are born. It is a huge clump of gas and dust particles. Eventually, gravity will collapse this structure, and as it collapses, the force of gravity increases the kinetic energy of the particles. Hydrogen atoms gain enough energy to collide and combine to form helium atoms through the process called nuclear fusion. In a nutshell, nuclear fusion happens when atoms gain enough energy to combine when they collide. This process releases huge amount of energy. Have you ever wondered why the sun is so hot? Where does it get its energy from? It gets its energy from nuclear fusion. When 4 hydrogen atoms combine to form helium, some of the mass of hydrogen is converted into huge amount of energy. This energy blows the contents of the star out, but instead of being ejected, the contents of the star are held in place by gravity. When the star is at this stage, we say that it is in its main sequence stage. Currently, the sun is at this stage. Now, what happens inside the star in its main sequence stage depends on how big it is. In other words, different types of nuclear fusion happens inside the star depending on how big it is. For medium-sized stars like our sun, the proton-proton chain reaction is dominant. For more massive stars, the CNO or carbon-nitrogen-oxygen cycle is more dominant. The proton-proton chain reaction starts with 2 protons or 2 hydrogen atoms colliding and combining. As they combine, one of the protons turns into a neutron. Because of this, a positron and a neutrino are released. The positron will annihilate with an electron and release energy. We talked about this earlier. It was mentioned that protons can turn into a neutron and neutron can turn into a proton. Now, what we have left is a deuteron, which is an isotope of hydrogen. Later, another proton hits deuteron and helium-3 is formed. When this helium-3 meets another helium-3, which was formed from the collision and combination of other hydrogen atoms, they collide and they combine. Two protons will be released to perform another nuclear reaction. And that is how helium is formed through the process of proton-proton chain reaction. Back to you, Teacher Iman. That is how the light elements were formed during the Big Bang nucleosynthesis and how some light elements were formed during the stellar nucleosynthesis. Let's have a little review and see how much you learned about element formation. At the beginning, we reviewed 8 important concepts that will help us understand how elements were formed. These are: number 1. All atoms are made up of subatomic particles called protons, neutrons, and electrons. Number 2. The identity of an element depends on how many protons it has. Just look at the total number of protons that an atom has and you will know what type of element it is. Number 3. The light elements hydrogen, helium, lithium, and beryllium were the very first atoms to form. Number 4. Nucleosynthesis combines nucleons to form new elements. To form a new element, all you really have to do is to collide particles and combine them. Number 5. Big Bang is not an explosion. It is the expansion of space. Number 6. As the universe expands, it cools. This tells us that the universe was hot before, hot enough to energize particles to combine and collide. But as the time went by, it became cooler and cooler. Number 7. The higher the energy of the particles in an object are, the higher the temperature of that object will be. Number 8. Mass can be converted into energy. We also learned that a few moments after the Big Bang, protons and neutrons were formed. For a few minutes, the universe was hot enough to make the combination of these subatomic particles possible. And because of that, helium, lithium, and some beryllium were formed. However, when the universe was no longer hot enough, the nucleosynthesis stopped. The story of the elements did not end there though. Stars were born and nuclear fusion occurred at their core. Inside, hydrogen atoms combine to form helium and release energy. Now it's time to show how much you have learned. Please choose the letter of the best answer. Let's start with an easy one. Question number 1. Which of the following is not considered as light elements? A. Helium, B. Hydrogen, C. Lithium, or D. Iron? The answer is D. Iron. Question number 2. Which of the following is true about nucleosynthesis? A. It is the division of atomic particle. B. The combination of elements to form compound. C. It is the creation of everything including all matter in universe. D. It is the process of creating new atomic nuclei from pre-existing nuclei. The answer is D. It is the process of creating new atomic nuclei from pre-existing nuclei. Question number 3. At which phase of star life cycle is our sun in? A. Main sequence star, B. Planetary nebula, C. Red giant, or D. White dwarf? The answer is A. Main sequence star. Question number 4. How is the energy of the star produced? A. By combustion, B. By decomposition, C. By nuclear fission, or D. By nuclear fusion? The answer is D. Nuclear fusion. Last question. Which type of nuclear fusion occurs at the core of a medium-sized star? A. Alpha ladder process. B. CNO cycle. C. Proton-proton chain reaction. Or D. Tri-alpha process. The correct answer is C. Proton-proton chain reaction. Before we end this episode, I'd like to share something that I hope will encourage you in this new learning setup. Many people may express doubt on your ability to learn without a teacher teaching you face-to-face. Remember, you can choose to be like the moon that always depends on others to shine, but you can also choose to be a star that shines whether or not there is light around. Congratulations! You have reached the end of the very first episode of Science Eskwela TV. On our next topic, we will talk about how the heavier elements were formed inside the stars. Don't forget to come back next week for another episode because learning science with Teacher Iman is fun!